Alright, polarity. It's a little table here with three chemicals that are very similar: propanol, propanal, and propanone. They've all got very similar masses, molar masses, 60, 58, 58. But what you notice is their boiling points are completely different. Okay, let's look at the structures for these chemicals here, and we'll talk about why polarity makes them have different boiling points. Propanol, we'll just draw the end of it. So propanol is, how many carbons is pro, according to your little sheet that I just gave you? 3. So we'll just do 2 there.
Are we drawing them all or just one?
When we're looking at alcohols, aldehydes, and ketones, so all alcohol, aldehyde, our own ketone, so alcohol, aldehyde, ketone type different groups of organic molecules. These all have 3 carbons. They've all got very similar molar mass, 60 and 58. The only difference is that one's got extra hydrogens. As a general rule, the alcohol will always have the highest boiling point. So if we chose 4 carbons and did butanol, and butanal and butanol has the highest boiling point. Alcohol, doesn't matter how many carbons we choose to look at. But there's very little difference in the boiling point between the aldehyde and the ketone. Okay, 48 and 56, difference of 8 degrees, 97. So a difference of 50, almost 40 to 50, right? So it's way higher. And the reason is because of the polarity. So we need to identify some differences in electronegativity from low to high in these 3 molecules, and then we can have a look at why one of them is more polar than the other ones. So we'll look at the first one, right? We won't worry about this because hydrogen and carbon have very similar electronegativities. They're what we call non-polar. There's not enough of an electrical attraction difference for electrons between those two for any polarity to occur. So that whole section there is what we call non-polar. So we don't care about that. I'm doing non-polar and polar. I remember that. Yep. However, if we look towards this side of the molecule, right, we've got this here. This is our alcohol functional group. OH represents alcohol. If we look at the differences in electronegativity between O and H, H is the lowest, oxygen is very high.
Yeah, if there's a difference, it's polar, isn't there?
Yep. So there's a huge difference in electronegativity here, right? It means that the oxygen is pulling the electrons closer to itself from the hydrogen, because they're sharing electrons in this instance, right? So between that and that, we've got an electronegativity difference. Therefore, this group here is considered to be polar, this bond. And we signify that by using these little delta negative and delta positives. Remember doing that? Right? Do you remember how to know which one's negative, which one's positive? Okay. As a general rule, the high ones will take the negative, low ones will take the positive. Right? The reason is because the ones with high electronegativity, they're pulling attracting electrons. They're attracting the electrons in this bond here. They're pulling them closer to themselves, so they get partial negative charge. They're slightly negative compared to the other one, which becomes slightly positive. To go, yeah. So that's what we call a polar bond there. Also, what about this difference between carbon and oxygen? Right? We've got a carbon-oxygen bond there. Okay? So we can also have a little bit of polarity here too. Okay, look at the next one, right? We've got a CH bond here, no good. CH is similar electronegativity, no polarity, but we've got this CO bond, CO on different electronegativity, so we've got a little bit of polarity here. Which one gets positive, which one gets negative? Good.
Negative is the oxygen.
Negative is the oxygen, so a little S for the negative, S for the positive. Okay, so we've got some polarity in there. And that's it. That's the extent of the polarity, not much. So on this one here, we've got that same bond. So with our aldehyde, the carbonyl group of the C, double bond O is on the end. It's polar on our ketone group, it's in the middle, and it's polar. This top molecule is the most polar because of it's got 2 instances of polarity where these two only have 1. That explains why it has a higher boiling point than the other two. So at least what we've covered here is how to identify polarity. Yes? Looking for these chemicals here and